Hi, the section 3H, the unknown interest rate. So we have covered unknown interest rate in section 2.b. So this is a kind of review, but the example is more complicated. Example 1. So $100 deposit is made each month for 4 years. So each month, so the payment frequency is month, and 4 years. So that means n is equal to 48 because 4 years is 48 months. Beginning from 1 month from now. So this is annuity immediate situation. And the accumulated value at 4 years from now is $6,000. So AV is $6,000. And determine annual effective rate. So there are several points. So the first point is the payment frequency. That should be time unit. So this is 1 month. And the second point that we have to determine annual effective rate. So we have to calculate quarterly effective rate. I would say J first. Then annual rate I. Then calculate annual rate I. And the third point is actually the J cannot be solved analytically. So no analytical solutions for J. So use BA2 plus to get J. So as I mentioned in section 2.b, the calculator is really needed mathematically. So some questions cannot be solved analytically. So you specifically need BA2 plus or equivalent calculator. Okay, so now that we think about the time diagram, so payment frequency is quarterly. So we have the 48 payments. So the situation is 0. Okay, so the time unit is months, interest rate is J. We have 48 time points, the 1 up to 12, 13, up to 48, and the $100 each. So deposit was made, and we want to calculate accumulated value, and that is 6,000. So this is already given, so we can get J from this information. Okay, so now from this time diagram, so from the conditions, $100 times S, right angle 48 at J. This is equal to 6,000. And so that is, okay, so S right angle 48. So 100 times 1 plus J to the 48th power minus 1 over J. This is equal to 6,000. Okay. So yeah, you can cancel 100 and 6,000. So we have 60 here. But anyway, this is the equation of J, and the degree is 48. So we cannot really solve it by hand. So 48 degree. Equation for J. No analytical solution. For J. So in BA2 plus, you can input this information. So this 100, 100, 100. So this is payment. And this 48 is N. And interest rate, we want to calculate this. So this is accumulated value that is noted as the future value here. So in BA2 plus, we have to do, okay, so at first, clear the memory. So the second, the clear CVM, TVM, time value money function. Okay, then after that $100 payment, maybe we can put as negative because we have to put the one cash flow as negative and the other side as positive. So 100 plus minus payment. So negative 100 payment. Then 6,000. This is the future value. 6,000, the future value. Then 48 is the number of payments. So 48N. Then we want to calculate J. So the compute J, compute interest rate. So I over Y. Then we get the J is equal to 0.9196. So this is percent. So if you use BA2 plus, the unit is percent. So 0.9196%. So we can get to J first. So quarterly effective rate. Then we would like to calculate the annual effective rate. So what is I? So 1 plus I is equal to 1 plus J to the 12th power because the J is quarterly effective rate. So that means I is equal to 1 plus J, so 0.009196 to the 12th power minus 1. So this is the annual interest I. So this becomes 11.61, 0.1161 or 11.61%. So now we get the interest rate I. So this is how to solve this question. So at first, the payment frequency is quarterly, and we have to translate quarterly effective rate to annual rate, and the no analytical solutions for quarterly effective rate. So we have to use the calculator. Yeah. And in this case, okay, if you don't have a calculator, you cannot calculate the exact I. But is there any some rough approximation to get I without using calculator? So we want to discuss that. So a method of method of rough approximation on I. So okay, so we have 4 years. 4 years. So you make a deposit over 4 years. So that means on average, the amount your deposit is in the account for 2 years. So your money will earn interest for 2 years because the first payment is 1 month from now, so almost immediate, and the last payment is 4 years from now. So on average, the money is in the account for 2 years. So 2 years of interest will be accumulated. So 2 times I, 2 years of interest is amount of interest. So this is the amount of interest over principal. Total deposit. And the total deposit is $100 times 48 times, so 100 times 48. And the annual interest, amount of interest is 1,200 because originally 6,000 was the future value, accumulated value, and minus deposit. So this is the 6,000 minus 4,800, so 1,200. So this is equal to what? This is equal to 0.25. So that means I is approximately 0.125 or 12.5%. So it's not very close to 11.6%, 61%, but at least it's a reasonable guess for I. Yeah, in a usual year, in face-to-face classes, every time I solve questions, that I ask students what's the approximate answer. Then some students really have a good sense of numbers, even better than me, and they make really the close guess to the exact answer. Yeah, that is probably a different the ability than the mathematical abilities, but that is also important in the finance and actuarial mathematics.